So haloalkanes are formed after an alkane is halogenated, and the bond connecting the carbon to the halogen is a polar bond. So the halogen is partial negative because it is much more electronegative than the carbon atom, so the halogen will hog the electrons, leaving the carbon partial positive and resulting in an overall net dipole in this molecule. So X is a halogen, and the major halogens in organic chemistry are fluorine, chlorine, bromine, and iodine, and depending on which is bonded to carbon will affect that bond strength. In their group in the periodic table, fluorine is followed by chlorine, then bromine, then iodine. And we know going down a group is associated with an increase in atomic radius, so fluorine is the smallest radius, followed by chlorine, then bromine, then iodine. And this radius affects the bond length between carbon and the halogen, so bond length will be smallest for carbon and fluorine, a little larger for carbon and chlorine, a little bit larger than that for carbon and bromine, and finally it will be the largest for carbon and iodine. And the consequence of this longer bond is that it is also a weaker bond. So longer but weaker. If you look at the bond between carbon and fluorine, it's very short, but it's also the strongest bond of these halogen carbon bonds. Carbon and iodine, on the other hand, is the weakest because it is the longest.